Okay, so I noticed you got a few of the questions that you had asked in your email, so I'm just going to the first one that you're still missing. So Kayla is planning for retirement, and she estimates that she'll want to be able to withdraw $1,500 each quarter for 24 years once she retires. She opens a Roth IRA and finds investments that she expects to return 2.5% interest compounded quarterly. How much will she need to have in the account when she retires in order to meet her goal? Okay, you got that. And then how much will she have to deposit each quarter for the next 40 years in order to get this balance at retirement? All right, so we're going to have to do a savings annuity problem because she's going to try to save up this $108,039.40. All right, so, and it looks like you were really close, so maybe it's a rounding error. We'll see. All right, so I'm going to write down the 108,039.40. And let's notice that she's going to have 2.5% interest. It's going to be compounded quarterly. So if we go over here, let's grab our savings annuity formula. Here it is. And I'll put that up here. All right, now let's fill in. All right, so we already know that it's going to be $108,039.40. And we don't know the amount of the deposit. That's what we're trying to find out. We'll have 1 plus, it's 2% interest, so it's 2.5%, so 0.025 for R. We're going to compound quarterly, so that's 4 times. We're going to do this for 40 years, so 40 times 4. Minus 1. And on the bottom, 0.025 over 4 again. All right, so let's work out the 1 plus 0.025 divided by 4. That is going to give me 1.00625. And we'll go ahead and multiply the 4 times the 40 to get 160. And then also on the bottom, I'll have just the 0.00625. And then let's keep going. Let's take the 1.00625 to the 160th power. And that gives 2.709835576 minus the 1. All right, and then we want to subtract the 1, which is going to give us 1.709835576. And now in our next step, we can divide out the 0.00625. So I'm going to go ahead and do this divided by this. And that gives 273.5736922. And then, of course, lastly, to solve for D, you want to divide that out. All right, so we're going to get $394.92, which is exactly what they have here. So somewhere you went awry over here, perhaps rounded too early or something. All right, so of course your answer to C depends on B, how much interest will her deposits earn between now and retirement. So we need to take the $394.92 and multiply it times 40 years and times quarters, which will be 4 times per year. So let's take 394.92. It's being compounded 4 times a year, or she's paying it 4 times a year, and she's doing that for 40 years. So she's going to end up putting $63,187.20 in the bank. However, let's remember that this is how much she's going to have at the end of that 40 years. So the interest is quite substantial. Oops. 40 minus the 63,187.20. So 44,000, let's see, 852.20. Which 4,852.20. Yep, that's exactly what they've got there. All right, so let's see, you also had number 33, so let's go down there. Find the final amount of money in an account if $6,500 is deposited at 2.5% interest compounded quarterly, and the money is left for 5 years. Now, this is so close that I think you must have rounded something wrong. So we'll take a look. So let's notice we're only depositing one time. So it's being compounded multiple times, but we're only depositing one time, which makes it a compound interest problem and not a savings annuity problem. So let's go to the sheet, and the compound interest formula is right here. And I'll grab that, and then we'll get all of our information. All right, I think I'd better get a new sheet. Okay, so going back, we are putting $6,500 into the account. That's going to be our P. We are depositing at 2.5% interest quarterly, so 4 times a year, and we're going to leave it for 5 years. All right, so let's fill into this thing using my draw feature. 0 is 6,500. That's actually you. And then let's see, 0.025 for our interest rate, or 2.5% interest, but we're going to do compounding 4 times per year. And let's see, 5 years times 4. So let's first enter 1 plus 0.025 over 4 into the calculator. And that gives me 1.00625. I think that's the same amount we had in the last problem. We have it to the 20th power. And now let's take 1.00625 and raise it to the 20th power. and that gives us 1.1327 07738. Whoops. Well, that was weird. And then lastly, we want to multiply that times our 6,500. And we get 73, 62, and 60 cents. Okay, and so let's see if we go back here, 73, 62, and 60 cents. So somewhere you just got off in your decimal there. Okay, so let's see what your next one was. Still have room on this video, perhaps, to do one more. So you deposit $2,000 in an account earning 2% interest compounded monthly. How much will you have in the account in 5 years? Again, this is our compound interest because we're only depositing one time. So we've got 2,000, 2%. Monthly will be 12 times per year for 5 years. And you're close again, but somehow getting off in your calculations. So let me just use the same sheet here, since we're using the same formula. And we'll have P sub 0 in this case will be 2,000. 1 plus 2% will be 0.02. 12 times per year since it's monthly. And we're doing this for 5 years, so 5 times 12. Okay, so let's put 1 plus 0.02 divided by 12 into the calculator. That gives 1.001666667. And then, of course, multiply the 5 and the 12 to get 60. Now we've got to take our 1.001666667 to the 60th power. And that gives 1.105078927. And now finally, if I multiply 2,000 times that number, it's 2210.16. And if we look back, where was that one? 2210.16. Okay, so somehow you just got off in your decimals here. All right, for the last one, I'll have to use a different video since I'm running out of time on my video.